Hi, and welcome to our webinar on ML-driven credit risk using Neo4j features. I'm your host, Nathan Greenhut, our head of accounts for the Americas, and I have with me Yogesh, who is our head of solutions here at HopsWorks. Today, we're going to show you how to scale your AI, make better predictions, and get a better return on your investment. Yogesh.
And thank you very much. Hi, everyone. This is Yogesh. I'm the head of solutions at HopsWorks. I'm going to be presenting the webinar today, and we'll go through some quick slides and then switch into a live demo. And then post-demo, we can take some Q&A. I'll try my best to cover as much as possible in this session. So we are going to talk about the why machine learning is driving the credit risk decision for the banks. Banks are really using traditionally it has been a rule engine, but now in the new generation, all the credit risk decisions are being made with the help of machine learning algorithms. So we are going to show you how exactly HopsWorks as a platform is the right platform for building this kind of applications. And then also we'll go over the solution overview and the benefits of it, how to get started in terms of using HopsWorks for this use case. And then we'll take a live demo that how we have actually configured this application for our existing customers. So moving on, sorry, I have a bad throat today, so please don't mind. Try my best. So why companies are really, like trying to get into AI, right? Everybody knows that AI, the machine learning algorithms, has got a lot of predictive power, which is like basically something that has never been explored before, right? So companies want to use the unexplored, the insights out of the existing data and be able to do predictions and make real-time decisions. And that's where AI is taking a front seat. And we being a HopsWorks platform, we are a platform which is an enterprise-grade platform which comes with all the enterprise features, all the way from building your application to deploying to managing, monitoring, and so on. We are going to go through all the features of the HopsWorks that are the key features, why this platform really makes a perfect fit for this kind of use case. But these are some of the testimonials from our customers who have really leveraged the power of HopsWorks and build their application from scratch, and not one application, but multiple applications. Okay. So coming into, I just mentioned about multiple applications, right? So obviously your enterprise is not going to have one application or two applications in ML or AI, right? You have multiple teams, you have multiple use cases. So you're going to be dealing with a lot more use cases if you're using machine learning and AI within your enterprise. And at that point, you have two choices. Either you can buy separate solutions or separate products, or you can, everybody can work in silo and they can do their coding and then bring all the code together, which obviously involves a lot of effort in terms of optimizing the code and integrating the code and making sure all the predictions are accurate and they're working at scale. That's all is required to make everything functional. So this is how enterprises are operating in the absence of a unified platform or a platform which is a single platform for multiple applications. So what you see on the right screen here is like all these applications can be built using like one single platform, which is HopsWorks, and we have APIs available for you to be able to build the applications as well as integrate to your downstream application to make decisions in the operational world. So we are going to show you two different ways of building applications. You can use our APIs, which can be invoked through your coding language like a Python or something. And you can also use a no-code accelerator, which allows you to accelerate with some pre-built applications and pre-built modules, which is going to speed up the time or the speed of development. So what problem we are really focusing on, right? As I mentioned, I touched upon a few points. Like if you're trying to build all these applications in silo, then obviously you have a lot of consistency issue in terms of how the coding standards are. You don't have any governance. Governance is a nightmare. And again, once you integrate everything, you just need to make sure that it's working with the best of the technology and the best of the speed. It can lack a lot of enterprise standards, and that can lead into other issues. And eventually, you're not going to get accurate predictions. You're going to be creating like a spaghetti system. So to avoid that, what we are really suggesting here is to use a platform like HopsWorks, which has got all the required ingredients, right, in terms of building your apps. You need a platform that can connect to your variety of data, like different data sources in your enterprise. You need a platform which can allow you to build these applications with a low-code approach so that you can build your apps faster. You need a platform which can also help you with governance and auditing and scalability and logging and troubleshooting and all of it. So when we talk about an enterprise ready platform, we are not saying a bunch of scripts. It's really a platform which comes with a user interface, and you have the engine underneath which can take care of all of this, right? And that's going to increase your time to build application, in the sense, like, not time to build application, but you're going to be building faster applications in terms of the development. And basically, you will have a faster time to market, right? And once you do that, then you will have consistent view of all your data. You'll be able to consistently make predictions with the same data at a given point in time. So if there are multiple models, they all can you leverage the same version of the data, and that will eventually lead into a better accuracy and better prediction, which will obviously give you a better business value for your businesses. So that's what HubSpot is all about. Obviously, you want to build something which is better, faster, and cheaper. Right now, every time, like, if you want to do better, it doesn't mean it's going to be faster or cheaper, and vice versa. So you want a platform which can cater to all three of this. They are kind of very interconnected in terms of generating its value. So with this platform, you'll be able to do better predictions because of the reasons I mentioned, where you have data consistency, you have lineage of the information, you are able to collaborate with other users on the same platform, and that reduces your time in terms of redundancy and modularizing your code. And you get all the governance and the security features. So that's really making sure that you're using the right standards to build an application, and it's being governed at the same time. Okay. You also want to make sure that, once you build your apps, you have an API available so that you can integrate within your application. I mean, what good is an application if you are doing predictions, but you're not able to consume these predictions in real time or through an API? Because then you have to write another facade on the top of it. So out of the box, HubSpot is going to provide you those APIs where you can push the features, where you can read the features, where you're able to do predictions in real time. You can do in batch. So we have online and offline stores, which is going to scale basically along with your data. If you're doing a large volume, you may run in a batch. If you're doing like individual predictions or individual transaction level predictions, they're going to be more like a real-time APIs. So all of this can be done, and we have some numbers. We're going to be sharing our benchmarks, and overall, it's going to increase your productivity for your developers, so that people who are not familiar with like dealing with like hundreds of libraries in Python. This is a pre-packaged platform. You have all the right libraries available within the platform, and obviously you can add more to it. But on day one, you're not like starting from scratch. You are providing a platform to your business data scientists who are going to be having all the libraries in place, and they'll be able to right away start building applications. Again, if they're not very familiar with Python as a language, we have a low code accelerator that's going to help you further in terms of accelerating the development without knowing too much of coding. So we have both the options. We have options for both the community of users, right? And that's going to obviously reduce your it's a faster time to market. It's going to lower your TCO, the total cost of ownership, because of all of these out of box features, which is making you more productive. And also you are not dealing with like inconsistent data and wrong predictions, which can take a lot of more time of human, which is nothing but adding to your cost. So all of these savings are going to help you to make your applications build faster and cheaper, and then build more and more apps as you go along. So here are a few benchmarks that we have provided, and we also have linkages where you can go and actually start studying about what were the parameters used to do these testings. So as you see, there are three high-level benchmarks that we are sharing here. One is on the online reads. So this is when you want to do real-time predictions. So we have benchmark against other our competitors or competitive platforms, and we have done better in terms of like 10 to 12 times better when it comes to online read. And throughput is really important, right? I mean, if you cannot generate your predictions in nanoseconds and milliseconds, you won't be in business, right? Because let's say if you're trying to solve a fraud use case and you want to stop a transaction in real time, and if you don't have this kind of performance where you can do millions of rows per second, then it's not going to actually solve your problem, because you may build a great model, but a great model is no good if you cannot serve the model in real time at nanosecond or millisecond latency. So the platform comes with those pre-tuned gadgets, and all these. You're basically going to use these libraries and the whole optimal configuration of the platform, which is going to help you do your predictions in real time. When it comes to an offline read where you want to like do a high throughput or maybe like a batch prediction, we are still doing like 8 to 9 times better on that. When it comes to offline write, which is basically writing into the feature store, like your features that you're computing, and like maybe you want to do in a batch mode. Even there, we are like exceeding the competitors in terms of like having a 7x speed. So we have various links here. You can click these links, and we are going to be sharing those links as well. And then you can go through, what parameters were used, what environment was used, who are we benchmarking against, and so on. So apart from the performance part, right, availability is also a big question when you're dealing with an enterprise platform. So the platform comes out of the box where you can do an horizontal scale in terms of serving your models, and also you can do cross-region replication. So you may have features or data scientists sitting in different geographical regions. There, it could be because of cross-border restrictions and things like that. So these data scientists can actually do their feature engineering locally, and then once the features are loaded, which are more like anonymized or and identity, like you putting just an ID instead of names, etc. All of this can be done. They can upload into their local regions, and then these things can be synced across regions. So we have a cross-region replication available in case you are a global bank with operating in multiple countries or multiple regions. Okay. This is another high level overview of the platform. So just giving you different perspectives of the platform so you understand the idea behind it. So HubSpot's platform, these are the core components. You have components which are like you have a collaborative UI. So you have your user interface where you can do your feature engineering, you can do training of the model, you can do inferences, you can build APIs, and you can then start serving to your downstream applications. We also have like user interface to pull your data, do some ETL if you would like to, and if you want to build dashboards and so on. So there is a very rich user interface which allows you to do all of this in a very low code fashion. Then we have an API layer. If you want to build your own UI, or if you want to integrate directly to your in-house tools, or maybe tools that are already in existence, then you can connect to the APIs. You may have an application, a business application, which wants to consume predictions in real time. That's when you can use API as well. Also, you can use API if you're doing programming, like using Python program to do feature engineering, to build models, predictions, and so on. So all of that can also be done. So these APIs are of two different types. One is the Python API, which is more for Python programmers. And then you have REST APIs more for the web applications who want to consume this. At the core of it, we have two different stores, the online store and the offline store. I mean, it's not really replication of data, but the reason we are having these stores so that we can give you an optimal performance depending upon what type of use case you're solving. So if you're solving something which is AML, which is like batch in nature, you can go to an offline store. If you're doing something like a fraud, which is more real-time use case, you can go to an online store. So these different stores and different technologies under the hood is being taken care by the HubSpot platform, and that's going to give you the performance that you're looking for. So the platform itself has all these components. Now, using these components, you can obviously build applications, and there can be different applications. We provided a few examples here, and these are the applications that our customers are actively using across the platform. So you have a chatbot, you have a customer analytics application, a fraud detection, a credit risk, and so on. So you can literally use our application layer as well to start building your apps. But if you have an existing application, you can slide right into this blue box and then start integrating to the underlying platform through the APIs. So there are options. We have a framework for you if you like to use it, which is an AI-enabled application layer, or you can use even integrate your custom applications if required. In terms of the data flow, as you can see, your data is going to flow from various stores. It could be a data warehouse, a data lake, a document store. So we support all types of data stores, right? We support RDBMS, we support NoSQL, we support graph databases, we support vector stores. So we have connectors built for them, both for batch and real time, and you can feed into the platform. Feeding into the platform is nothing but doing the feature input. So you're inputting the features in the platform, and then we can do the feature engineering. So you can bring in your raw data, we can do the feature engineering on the platform, generate the features out of it, because some of the features are going to be just lift and shift from the input data, and some of them will require some kind of derivation or calculation. So you can do that as well. So you can do all your feature engineering here. You can do model training and prediction and inference and all of it. So basically, all of this, like in terms of pulling the data, transforming it, preparing, and get to the final model, all this can be achieved like in 3 weeks of time. It doesn't take more than that. And the reason we are able to achieve this, and we have proved it with our customer, so the reason we are able to achieve it because we have already pre-packaged all the libraries that are required to build your applications. Not just the libraries, but also the high-level components which are required to build an app. So you need a ETL component, you need a data quality engine, you need a feature engine, you need a machine learning model engine, which allows you to train your model, do predictions, and then finally, take actions upon it. So we have a workflow engine too. So all of these engines are put together, including all the way from the libraries, which is more low level. And then everything on the right you see are the various applications, the ML application that has been built, right? I'll take a brief pause before I dive further into the features here. Nate, do you have any questions for me?
Yeah, there's one question on algorithms. What types of algorithms can you use within HopsWorks?
Well, out of the box, you have like, more than 50 plus algorithms, and these are the libraries which are pre-configured within the platform. They come from scikit-learn and other libraries. But if you want, something different, then you can go to the user interface and you can just type in the name of the algorithm or the library, and in less than few seconds you can install it. But you have at least 50 plus available at this point. I mean, there could be more into it, but I'm talking about the top 50 which are used in 95% of the use cases. So you're gonna probably hit uh, the requirement that you're looking for.
And then Yogesh, one other question is what data sources are available or can you give some examples
Yeah,
as
so
well?
you can use any traditional RDBMS all the way starting from MySQL to Oracles of the world. You can use like cloud databases like Athena or DynamoDB or maybe like Snowflake. You can pull data from there. You can also use NoSQL databases like MongoDB or Cassandra or maybe a graph database. And you can also use a key value store if you like, Redis and a few others, along with RonDB or maybe a feature vector store. So pretty much we have coverage. These are very generic connectors. So you can literally connect to most of the databases that are being used or certified for enterprises. Anything else, Nate? Any other questions?
That's all at this time. Thanks, Yogesh.
Okay, thank you. Uh, so further diving into the HopsWorks feature store, right? So a feature store basically does what? It holds features, and features are nothing but individual attributes or input that goes into a model. And when you when you bring together all this feature, you call it a feature group, and then you create feature view out of it. So there are two concepts that you need to keep in mind. One is feature group, which is basically a grouping of features. So I can have a feature group for, let's say, risk model. I can have a feature group for customer analytics. I can have a feature group for accounts and so on. And then I can create views on the top of it by joining these data sets or feature groups to create a view that is specific to a use case. So feature groups are going to be more aligned with your enterprise entities like customer accounts, transactions, products, and so on. And feature views are going to be more aligned with your use cases that you're trying to solve. Because you may want to do a mix and match when you're solving a fraud detection use case. You may want to know some customer attributes, and you may also want to know some account attributes and some transaction attributes. So you may end up like joining like three different feature groups right for into one feature view. Okay. So you don't have to really take the data out and join everything. We have APIs which allows you to create these features and do joining and all of that. Okay. So creating a feature view is basically, let's say you have loans and you have applicants. So you can basically select everything from loan, everything from applicants, and you can say where the label, you can define your label column, you can provide some kind of filtering, you can do some transformations along the way, and then finally you can create the feature view. So in one statement, or you can say like few lines of code, you can join, you can filter, you can aggregate, and you can transform. Okay. And then you can use that data for training or inference, depending upon what's your requirement. So further diving into the use case that we are focused on today. So today we are going to talk about the credit risk use case where the analysts are making decisions in real time while underwriting a loan, and then making sure that the limits they're reimbursing the loan to the right people or approval to the right people, and protecting the organization from happening any fraud and things like that. So what we have done is we have created two or three different models, but the gist of these models, like the core components of the solutions, are pretty common. So what we do is like, let's say you are into the credit risk world, you're going to have like, borrowers, which are nothing but individuals or people or persons. They can also be institutions, obviously. So which are nothing but entities. So what you need to do as a first step, you need to make sure that your entities are all resolved. If you have a good MDM system, you don't need to do this step. But if you don't have an MDM system and you may have multiple systems providing you borrow data, like over a period of time, you might have done some acquisitions. So you may have multiple loan management systems. You can take all of this data and make sure that your customers are matching with each other. So if you have the same customer across two different systems due to a merger that happened in the past, you can bring them together and you can say this customer is the same customer, right? So we can do the resolution for you at scale, at speed, because we have a module that is built in specifically for this, and we also use Neo4j, which is a graph database, to provide you that kind of performance. Okay. Then we use the entity, do the profiling, where once the entities are resolved, we profile each of the entity. We compute few attributes on a periodic basis. Once these entities are profiled, then we start running our behavioral analytics algorithms, the machine learning algorithm, the graph algorithms, do the predictions. And once you do your predictions, we can start scoring this. So you can aggregate all your predictions with the risk scoring, and then finally generate alerts. So alert is really the final stage of the application. But then if you want to go one step beyond, which is like taking an action around it, then you can start doing case management. So we have a case management module available for you to be able to consume these alerts, which also gives you the ability to create a business process workflow. So let's say an alert is generated, you want to start triaging this alert, but you want to keep a track of it. So you can create a case around that. And at the same time, you may want to inform level 1 analyst or level 2 analyst and so on. So you may have a very complex business process workflow for triaging these alerts or maybe approving your loan. So we provide you an out of the box business process workflow engine as a part of the accelerator, which will help you to build your applications faster. And then finally, every application requires some kind of visualization for your management, for your regulatory bodies, for your internal reporting. So all of this can be done right on the accelerator itself. So accelerator really is sitting on the top of the core HubSpot engine, which is actually doing all the heavy lifting for you. But the accelerator is allowing you to configure your various components of the business applications and build an end-to-end app, and not just one app, but many, many apps. Another slide. So this is about how the real-time credit risk engine is working. So we are receiving data from the left here, and they go into a Kafka queue, which is more real-time messaging queue. Then it gets into Neo4j. We do some feature engineering out there. We generate some features, we extract those features, and we push it into the HubSpot. Sometimes we also push data directly as a batch from the source system into HubSpot. So you have options. You have real-time systems sending data. You have batch systems sending data. And once all the features are available in the HubSpot, you can do the feature engineering. After the feature engineering, you can do the model building, the training, the predictions, and all of that. And once the predictions are made, then you can make its way into the alert engine, which will allow you to generate alerts and stop a transaction in real time. So if an underwriter was trying to approve a loan, we can stop that loan in real time. If there are some predictions, batch predictions in terms of who's going to default in terms of making the payments in the next month, we can do that as well. And I'm going to show you one of those examples. Also, there are analysts who are constantly looking at these alerts. So if they think this is a false alert, then there is a feedback loop associated, and we can basically take that feedback and we can retrain the model in future, which is basically going to reduce your false positive. You're going to get a better accuracy. Your analyst productivity is going to go up, and then you're going to generate more business value out of it. Okay, so it's demo time. So we are going to do a live demo of one of the applications. I'm going to show you a few screens of an application, how it's being built. We'll look at the HopsWorks core platform. Then we are going to look at the HopsWorks accelerator. And then we can go through a Q&A if you like. So while I'm switching into the demo, Nate, any more questions at this point?
Yeah, Yogesh, can you just give a little bit more of an overview of what other solutions there are on the HopsWorks platform again?
Yeah. So there was another slide. I went through that in the beginning. So there was a slide which showed you all the various applications. So you can do credit risk applications, you can do customer analytics, you can do marketing. There's no restrictions on what type of applications, but on an average, we have seen that our customers are building at least 7 or 8 different apps, all running on a single platform. So you can do all the way from your revenue generating applications to regulatory applications. Okay.
Thanks, Yogesh.
And
That's
now,
all the questions right now.
sure. So now I'm going to go into the HubSpot platform here. As you can see, I have different menus here. Today, I'm going to give a very high-level overview of what this UI is all about. So you have a home page, and where you can see, what are the recent activities that are happening. You can see there are feature groups, which I mentioned that it's a grouping of features, feature views, where you are kind of joining the feature groups, like creating a data set out of it. Then you have storage connectors, which will allow you to basically connect to different type of databases like JDBC and so on. You can also connect to an Hadoop file system. You have ingestion pipeline. Here you can start creating ingesting data into the HubSpot platform. Your model registry, which is going to allow you to build your models, keep a track of it, keep a track of the versions, deploy specific versions, and so on. Okay. And then finally, once your models are created, you can also deploy them, right? So we have a a serving component which allows you to deploy these models in real time and then start generating predictions around that. And we keep a track of every prediction that is being made, and that is the value of feature store. Like writing a bunch of code and building a model is one aspect of it, but operationalizing a model by keeping all these aspects in mind, like for example, when the new predictions are happening, you need to make sure that you need to encode the data that is coming in with the same methodology or the concept that you use during the training process. Otherwise, you're going to get very different results. So all this knowledge is already baked into the platform. That's going to help you make less errors and make better predictions, and obviously generate more business value. So today we are, as I mentioned, we are going to look at a credit risk application. So I have created a feature group for demo here. So I'm going to basically search for it. It's called branch loan feature dataset. So basically this is all the loans that are available and then all the attributes of the loan and all the payment that has happened against the loan. And we are trying to predict if this loan is going to be defaulted or not, or the borrower is not going to make a payment. Okay. So clicking on it, so once I click on the feature data set, which is nothing but the feature group, I can see what attributes are available within that. So there are around 15, 20 different type of features that we have created. Some of these features are coming right from the source systems, and some of the features are actually being derived. And I'll show you one feature calculation, how it's being done. So just to give you an example here, I'm going to log in into the accelerator. I'll go to the credit risk analytics application. Once I go in, I can go to data preparation, I can go to formulas, and then let's say I want to generate a borrower grade based upon some inputs. I want to generate a grade out of it. So here you can see I can define my logic. So through point and click, you can define the whole logic that if the score is between 0 and 499, then I'm going to call it excellent. If the credit score is between 500 and 649, and so on. So this is how you will actually do your feature engine. Now, some features are going to be very basic, like mathematical calculations, like divisions and ratios and things like that. Some are going to be aggregative in nature. Some are going to be like a complex business logic, like if then else. Some are going to use some predictive, like not predictive, but they're going to use some statistical functions. So, and maybe some features you may calculate with a very complex business logic, which is very unique to right? Your situation. So anything that's like, so what you do is like basically we have out of the box all these functions available. But if you want to build your custom business logic and use it for feature engineering, then you can create a small Python script and then you can kind of register that script into the platform. Okay, so that everybody who's using those features can use the same logic and maintain consistency. You get auditing out of the box, you get consistency out of the box. Okay. And then there are other features like provenance expectations. Expectations are nothing but a data quality engine which is inbuilt, so you can start configuring your expectations around the features, that what should be the ranges, what should be the values, like the list of values and so on. You can also do tagging. So tags are basically used for, let's say I want to tag that this feature store is ready to be used or it's production ready, or maybe it contains PII data. So you can come up with any creative idea, but generally it is to do with your process of development. You can define alerts that if some value is exceeding certain value or things like that, you can define alerts too. Now, if you were doing something programmatically, then you can use these API. So these are the pre-built APIs, like ready to go code for you to be, to be able to like go and start programming in the Python or the Scala world. So you can use this to connect to the feature store, and you can connect to a particular feature group and extract the data. Now, when you connect to the feature group, you need to define a version. If you don't define a version, it's going to give you the latest version, but otherwise you can define whatever version number you want. Okay. So every feature data that goes into the platform is being like a version, and you are able to do a time travel on it. So 3 months down the line, if you want to retrain a model using data that was generated like 3 months ago, you can do that as well. Either you can go by a timestamp or you can go by a version number if you know the version, corresponding version for that. Okay, so this is how the feature engineering takes place. Now let's talk about the model building. So I'm going to go into data science here. I'm going to look at the feature, like the feature group. So this was the feature group we were looking at. This is basically the accelerator for you to be able to build applications, without too much of coding. I can look at, so this is pointing to the feature store, which is HopsWorks. It's a feature group, as I showed you in the HopsWorks UI. And then you have all these features. So you can see here, we have more than 180 features. So I think there was a question at some point in one of the previous webinar, like how many features can it store? And literally, there's no limit because we are storing features as rows. So when you build a table or design something to store as rows, there's no limit to it, right? Now, if you're trying to build a model and if you're using pandas data frame or specific technology, there may be some limitations around that. But as far as my knowledge goes, it can take you up to like 60,000 plus features. So I think that's a very large number if you're dealing with pandas data frame or Spark data frames. Okay, but if you're storing those features into a database, then obviously the database might have its own limitation. But as far as I know, most of them allow like around 32,000 or so. So there's nothing to worry about how many features you can store, etc. Okay. So once the feature is stored, then you can start building the model, then you can do the training of the model as well. So let's see how the training takes place. I can, so this is the bounce behavior. I'm trying to study the bounce behavior of the borrowers. Are they going to bounce on the loans? So I'm pointing to, I've created a model. I'm pointing to my feature store, like where my data resides. I'm choosing what label column I need to pick out of the feature store, what's my row identifier, and what are the various features that are going to make its way into the model during the training process. Once that is done, you can do a lot of other clicking here, like you can you can turn on the hyperparameter tuning, you can do feature weight calculation, you can save your results, you can do a split like the way you want, you can put a seed around that. And then finally, you can say that I want to store this model into Hopsbox. So like in like 2 clicks, I would say in like 5 to 10 minutes, you can basically push your data into feature store and you can do some preparation if you need to, depending upon how many features you need to build. It might vary in terms of how much time it takes. But once your feature data is ready, going from feature data to like training a model is like less than 5 minutes job, right? Because you have all these algorithms available. So there was a question previously asked, like how many algorithms are there? So as you see here, there are 38 to 35, 38 to 40 algorithms. These are all the algorithms which are kind of pre-configured into the accelerator. But within the platform, you have every possible algorithm available, right? And if you don't have something, you can always install the library and then you can come to the accelerator and register that. So it's a very non-trivial thing is you can easily uh, you know install new libraries and you can configure new algorithms within the accelerator and the platform. Let's take a look at the results. So there are different type of results that are available. I'm looking at the training right now. So I pre-trained some model for you to save some time. There are 3 different models we have. We have done customer segmentation. We have done behavior bounces, which is more of a classification. This is a clustering algorithm. And the behavior moratorium is like basically where during the COVID days, we wanted to study the behavior that why some borrowers, even though they have a bad score, why they are not defaulting, or if they have good score, why are they defaulting? So we're trying to study the pattern and see that which borrower we should really, lend more during the COVID time, given that, like there is a pattern out there in the data. Okay. So we're going to look at the bounce behavior today. That's one of the models. So the model is trained using XGBoost algorithm. It's in Python. It has 46 features. We have taken some sample data. These are all the parameters that are being used. I can look at the feature importance. Feature importance is nothing but depending upon the number of features you're using, which features are most relevant for the model to be able to make a prediction. So age of the loan, high mark, and so on. Obviously, everybody knows age matters a lot in terms of your ability to pay back, right? Not always true, but it can be. Then your performance related feature metrics here, we show you like the accuracy metrics, the confusion metrics, how many predictions are happening, how many yeses and how many nos, basically who's going to default and who's not going to default. This is the AUC ROC curve. You can look at the actual train and the test data, the data that was used for prediction purpose. And you can also go to the feature weights if you want to see at like individual predictions that were made. Like if you have 100 borrowers and if you want to see a prediction for a particular borrower, like what drove the decision, you can click that borrower and then you can look at the predictions out of that. So these are all the predictions. The prediction was 1, which means the default, this borrower is going to default. And these are all the metrics which are driving it, the features. Okay. You kind of get an explanation. It's not like a black box then. Now we are also now we were looking at these results right now. What if you want to take all the steps and create a pipeline out of it? So what you can do is now before that, now we are at a stage where we've done the predictions. Now you want to take actions upon it. So you can configure a business rule engine. These rules are basically I want to look at all the risky loans which have been informed by my predictive model. So I can go and point to my predictions where my predictions are taking place, and I can say, tell me all the probabilities that are greater than 0.7, which is like 70% probability of defaulting. So I'm kind of picking all of them. I'm assigning a score to it, and I'm creating a score around it. Once the scores are generated, I can generate alerts around it, and then I can start looking into these alerts. So this is one of the alert which is created on one of the loan. It's a high risk alert, which means there is a high chance that the borrower is going to default on this particular loan. So I can look at the alerting details. I can look at the actual loan details. All of this is configurable through point and click. You can make this happen. If you have any number of attributes, they can be configured on this. If I want to look at the alerts which contributed to this case, so I can kind of drill down from here. So there are two different alerts that happen on the same loan, and then we have kind of clubbed them together to come up with a common case. I can also connect to my knowledge graph, which is a Neo4j database, and see like this loan belongs to which borrower and what product it is using. So it's using some product. I can also see if this borrower is using some other loan. So I can double click and I can see if there are any other loans outstanding for this particular borrower, and if it's the same product or a different product. It seems like there are two different products we are talking about. I can add some notes, I can do some documentation, I can keep a history of it, I can send notifications. And then finally, last but not the least, this is the business workflow engine I was talking about. So this is one of a very powerful feature within the accelerator, which allows you to now not only make a decision, but also take action after that. So let's say you made a decision that you want to kind of investigate into this borrower, because it seems like the system is selling and is making sense to you. So what are you going to do? You're going to generate an alert, assign a case to one of the analysts, and then triage that case, right? Triage the alert. But it cannot be a one-step process. In the practical world, it's going to be a multi-step process where you're going to read the case details, you're going to see which analyst is available, who is the right analyst based upon a region, geography, maybe some product knowledge, and then assign to that particular analyst. Once you assign to that analyst to a central examiner, then you can assign to level 1, level 2, level 3, and so on. Now, these level 1 reviewer can say, I need more information, and then your case can actually go back. So you can reassign this case to the previous reviewer and so on. So you can do all this back and forth. You can apply some business logic. You can send reminders. You can send notifications and so on. So you can be as creative as you want. You can also inform an application downstream by sending a message or maybe dropping a file or a flag or something in some database. Okay. So all of this can be achieved through the business process workflow engine. This is a very important aspect of building any applications, because generating predictions and like letting them sit in the system doesn't make sense. You need to kick some workflow, right? And then finally, you want to create visualizations around it, like dashboards. So we have few dashboards created here. For configurations, point and click, you can create these dashboards. So I have a dashboard to look at my complete loan portfolio. So I have total loans, I have approved the disbursed loans, and so on. Let me just refresh this. There's some network issue at my end. Yeah, so these are all the charts available. How many borrowers are there by each branch? How many different firm types we have, like, LLCs and so on. By tenure, like which are the, the longest, like the lengthiest loan we have in our portfolio. So we have, like in this particular case, around 270 loans, which are falling in the category of 36 months. So these are all different distribution metrics you can create. You can also kind of look at some 3D charts, like this is a three-dimensional chart to look at, your age versus borrower versus the turnover, right? So you can find some outliers here, and now you can start generating alerts or to take some actions against that. Similarly, we have other dashboards. So I wanted to study the bounce behavior, like why the bounces are happening. So we started comparing scores, the credit scores, like internal credit score, which is generated by our system, by the machine learning model versus, the score that comes from the third-party systems, the external credit agencies. So we kind of started comparing, doing scatter plots around the disbursed amount versus the bounce behavior. Is it really by the amount of the loan which is influencing the bounce behavior, or is it something else? We started looking at the scores, the external score, and compare, like CIBIL is one of the external agency which is providing the creditor scores. We started looking at the age of the loan versus the bounce prediction and so on. So there are different metrics we are comparing. We have also done something in the three-dimensional worlds when we did segmentation, like how this customer are getting segmented. So if you look in this particular one, we have different ratings for our customer or grades for customer. And you can see like the red is the poor, and the ones which are poor are kind of either they have not registered organizations or the age of the loan is very high, I would say. And also the business segment is like, a specific business segment. So you can look at these outliers, you can study them, and then you can start making decisions around it. Okay. So this is more like building dashboards and reports. And then finally, what you can do is you can take all of these steps and stitch a pipeline around it. So for example, we have created a pipeline for credit risk analytics. Uh, Drag and drop, you build your pipeline. So this is a pipeline which is basically taking care of three major steps. One is the feature engineering. So this is like feature engineering step. Then you're putting the features in the feature store. Then you're kind of training three different models. You can do in parallel, you can do in sequence, depending upon how much horsepower you have on the system. And then we are doing some predictions, evaluations of the model, and building some dashboard. So this whole application pipeline can be stitched together using this one single UI. You don't need a separate tool for that. Okay. So that's really the last part of the pipeline. So switching back here, as you saw, like we were able to build the whole application through the accelerator, and everything that is being built is getting stored here, right? So you have the features which are getting stored here. You have the models. So I can go back and I can look at the model registry to find the respective models that are available. Okay. And then if you want to do any kind of deployments, you can do that as well. So this is the deployed models. If you want to do a new deployment, you can do that too. Okay. So switching back here into the slideshow. So the demo is done. So just to summarize, and after the summary, maybe we will do some Q&A. Just to summarize what I've showed you today, that what's exactly a feature store platform, what's an enterprise machine learning platform, right? What are the kind of features you need if you want to build a successful journey of your AI ML applications? How it can save your time and money if you have all of these components available in a singular platform where you can build various applications. How can you make better predictions in terms of like continuously learning? You want to make sure that you have accuracy within your feature data. This feature data is available at the desired throughput, and in terms of your the timing, like millisecond response time, and then also in terms of the velocity, so that you can still start putting these features in real time using the Kafka queues, and we assure you that availability so that your applications don't suffer, right? All of this put together is giving you a faster time to value. At the end of the day, we want to make sure you can get these apps out faster to your business so that they can make good decisions, they can make real-time decisions, and then that's going to eventually save losses to the business in terms of revenue or in terms of the regulatory fines or any kind of fraudulent activity. And then obviously you can put this money back into the system here and you can build more applications out of it. You have both the options available. If you have a Python developer who wants to use the platform, they can use the Python APIs. If you have non-Python developers, or maybe they want to use a combination of two, like a low-code accelerator, they can do that as well. So some of the things you can build in Python and then kind of put them together into the accelerator, and then you can build the rest of the pieces into the accelerator if you don't want to go like crazy on the programming part. So yeah, so that's pretty much the end of the webinar. I'm going to hand it over back to Nate, my colleague here. And if there are any questions, Nate, I'm happy to answer those.
Yeah, there's a question on how to get started. How would you get started with HopsWorks, Yogesh, on your own, or even, with some guidance from HopsWorks as well?
Okay, so there are two options. You can go on the Hopson's website, and then there is an option where you can sign up for like a trial subscription. You can try for, I don't know for how many days, but you can check it out for a few weeks. Once that is done, then if you are ready to, once you understand the platform and if you want to now install into your environment, we have a cloud option where it can connect to your any account like cloud account, AWS or GCP, and it can kind of launch the cluster within your environment if you are very sensitive to put your data into our cloud. And if you are a complete on-prem customer, we can you can reach out to Nate or our sales team, and then we can basically install on a physical server or a virtual server or even Dockerize into a Kubernetes cluster for you.
Great. Thank you, Yogesh. And thank you, everybody, for joining our webinar on ML-driven credit risk. We really appreciate your time. We have webinars coming up in the next few weeks. Please stay tuned. And just in parting, we have, if you need to get in contact with us, you can come to our website, as Yogesh mentioned, and log in or use a contact us form, or you can email me directly at nathan.greenhut@hopsworks.ai. Again, thank you for joining ML-driven credit risk today, and we look forward to hearing and seeing from you again in the future. Thank you.